In lessons 6 and 7, we have been talking about the quantitative analysis of data. In other words, we're looking at different tools that we could use to analyze our quantitative data to try and discover behaviors and patterns within that data. And we've been using summary statistics as our tools. These summary statistics include the mean, the median, the mode, quartiles, or your 5 number summary, and then standard deviation and variance. We also ended with the z-score in lesson 7. Now, all of these are great for when we're trying to analyze a single variable. But can we find a relationship between two different variables? We see it all the time. For example, a relationship between sunlight and temperature. Or we might see a relationship between temperature and the amount of ice cream consumed, or the amount of rainfall and the amount of road work that needs to be done. I don't know. I'm totally making this up at the moment, but still, there are relationships between two quantitative variables. There are tools to help find this relationship, and that's what lesson 8 is all about, is finding these tools to find relationships between two variables. In this video, we're going to focus on the line of best fit. Now, to introduce this, we're going to review scatter plots for just a second. A scatter plot, you have an x variable and a y variable. You take a single observation, take its x value and its y value, and where they meet, you're going to draw a point there. Now, which variable is x, which variable is y? Remember that the x variable is going to be our explanatory variable, whereas the y variable is going to be your response variable. What's the difference between the two? An explanatory variable is more likely to influence the other variable, whereas the response variable is more likely to be influenced by the other variable. So here on the screen, I have a data set of height and weight. Ask yourself very quickly, which of these two variables is more likely to influence the other? Will height influence weight, or will weight influence height? Pause and think about that for just a second. All right, so hopefully you've had a chance to think about that. If I gain weight, will that change my height? No, not necessarily. That doesn't make sense. I'm at an age where my height is done. I'm not going to change my height very much at all. So I could put on as much weight as I want, and it will not change my height. But if I were to change height, would that influence my weight? Yes, it would. Having a higher weight, being taller, means you have more mass, so you should have a larger weight. So height influences weight. So height is going to be my explanatory variable, weight will be my response variable. And so you see my graph here, my scatter plot, height is on the x-axis, weight is on the y-axis. Now, look at the pattern of that data. You can see that the data is kind of all over the place, but it tends to follow a line. Now, I don't know if height and weight will really follow this line pattern. This is made up data, but you can see there is a linear relationship between the two. In other words, by a linear relationship, we mean that there seems to be some sort of a line that they are following. So we get to the linear regression, which is also known as the line of best fit. We're going to create a line that matches the two variables. Now, here's an equation, y equals a plus bx. Hopefully it looks familiar. If it doesn't, maybe this will jog your memory. Do you remember in other math classes, you learned this equation, y equals mx plus b? This is the equation of a line. M is the slope of the line, b is a y-intercept of the line. It's the same equation. We're just giving it a different name for the slope and the y-intercept. With y equals a plus bx, a will be your y-intercept, and b will be your slope. Okay, so we're going to create this line, y equals a plus bx, and by the way, the reason why I do y equals a plus bx is because that's the way it's going to be done on the TI-84, which is the calculator we recommend in the class. So I'm sticking with the y equals a plus bx format so that you see it throughout the course. All right, once you have the values of a and b, that's going to determine where your line is. Once you have it, you can actually use this line as a linear regression. By linear regression, we mean we can insert x variables and predict what the y variables will be. We'll do that in another video. But the point is, here's a line, y equals a plus bx. So we're going to take height and weight in this table. We've got a scatter plot. We're going to create a line of best fit that goes right through the data. Now you can see here that the equation is y equals negative 173.297 plus 4.829x. I will explain this equation in the next couple of videos on how to find this line of best fit in Desmos and on the TI-84. Both of these videos, I'll show you where these equations come from. But for now, we don't need to worry about where they come from, just how to get it. The equation is honestly a little more complicated. So once you use the calculator to find this equation, it's a line that goes right through the middle of our data. And in subsequent videos, we're going to talk about the relationship or how closely points are compacted to that line, or are they spread out from that line. Then we'll also talk about how to use this line as a tool for prediction.